How to find GCF by prime factorization. GCF stands for greatest common factor. In order to find the GCF, we need to use a process which is called prime factorization. We have covered prime factorization in our earlier videos. If you do not know how to conduct prime factorization, or if you want to learn prime factorization, please see our earlier video. The link is given in the description and also at the top of the screen. Thank you. We need to find out GCF for number 12, number 14, and number 13. So in order to find GCF for these three numbers, we have to factorize these three numbers individually by prime numbers. How do we do it? Start with 12. So if we factorize 12 by prime numbers, 12 being an even number, the first prime number we should try is 2. So 12 divided by 2 is 6. 6 being a prime number, 6 being an even number, we can factorize it by 2. So 6 divided by 2 equal to 3. Then comes 14. 14 being an even number will be divided by 2. So 14 divided by 2 is 7. 7 is a prime number. We cannot divide 7 anymore. Likewise, 3 was a prime number. You could not have divided by 3 with any other number. Now the last and third number is 30. 30 is an even number. So we can divide 30 by 2. And here comes 15. 15 is a number which has got 5 in the unit place, so it will be divided by 5. So here it is 3. So if we write down the numbers here, logically we can write 12 equal to 2 into 2 times 3. We can write 14 equal to 2 into 7. We can write 30 equal to 2 into 3 into 5. So we have to find out factors which are common in each row. So factors which are common in each row, we have got only one factor which is common in each of the three rows, that is 2. So the GCF of 12, 14 and 30 is 2. Another very interesting example, the GCF between 2, 7 and 15. So if we divide 2 by prime numbers, it will not be divided by any other numbers than 2 and 1. So we divide by 2, we get 1. If we divide 7 by any number, it will not be divided by any number other than 7 itself and 1. If we divide 7 by 7, we get 1. If we divide 15 by any number, 5 being in the unit place, 15 will always be divisible by 5. So 15 divided by 5 equal to 3. 3 is a prime number. It will not be divided by any other number other than 3 and 1. So if we divide 3 by 3, we get 1. So if we write down the numbers here, number 2 equal to 2 times 1. Number 7 equal to 7 times 1. And number 15 equal to 5 into 1 into 3. So we have common factor present in these 3 rows is 1. Therefore, GCF of 2, 7 and 15 is 1. We take another and last example. Let us take a combination of even and odd numbers. So we take 3 numbers. Out of 3, 1 is an even number, which is 20. Second is an odd number, which is 35. And third is also an odd number, which is 55. So we do prime number factorization of 20. 20 being an even number will always be divisible by 2. So 20 divided by 2 equal to 10. 10 being an even number will always be divisible by 2. 10 divided by 2 equal to 5. 35 being an odd number having 5 in the unit place will always be divisible by 5. So 5 divided by 35 equal to 7. 7 is a prime number which cannot be divided anymore. Likewise, 5 was a prime number which could not have been divided by any other number. Now we take 55. 55 is an odd number, but having 5 in the unit place will be divisible by 5. So if I divide 55 by 5, we have 11. 11 being an odd number cannot be divided any longer. So if we write down these 3 numbers logically, we'll have 20 equal to 2 times 2 times 5. We have 35 equal to 5 times 7. We have got 55 equal to 5 times 11. So if we want to find out that factor which is common in these 3 rows, row 20, row 35, row 55, we have 5 as a common factor. So the GCF of 20, 35 and 55 is 5. Now let's take another example just for our understanding, including 2 even numbers and 1 odd number. So we have got even number 24 and 18, and we have got odd number 21. Let us do prime factorization of these on these 3 numbers. 24 being an even number will always be divided by 2. So 24 divided by 2 equal to 12. 12 being an even number will always be divided by 2. 12 divided by 2 equal to 6. 6 being an even number will always be divisible by 2. 6 divided by 2 equal to 3. Next number is 18. 18 being an even number will always be divisible by 2. So 18 divided by 2 equal to 9. 9 is divided by the first prime number 3, which is other than 9 itself and 1. So number 3, 9 divided by 3 equal to 3. Now 3 is a prime number. We cannot divide 3 anymore. And here 3 was a prime number, so we could not divide 3 anymore. The next prime number is 21. 21, the first prime number, which 21 can be divided by, is 3. So 21 divided by 3 equal to 7. Now, if we write down the numbers logically, we have 24, which is 2 times 2 times 2 times 3. We have 18, which is 2 times 3 times 3. We have got 21, which is 3 times 7. Now, if we try to find out the factors or the factor which is common in these three rows, 24 row, 18 row, and 21 row, we find only one factor that is common in each of the three rows, and that factor is 3. So the GCF of 24, 18, and 21 is 3. So I hope you understood the concept of finding GCF. In the description, there are 60 questions given to you for your practice. Practice the questions and please leave me a comment if you find any difficulties. Thank you.